let A be the first term and D be the common difference. Then the general form of an AP is A plus D, A plus 2D, A plus 3D, etc. Now I give you some questions. Which of the following list numbers form an FE? If they form an FE, write the next two terms. 4, 10, 16, 22, etc. is an arithmetic progression. What's the next two terms? So to find the next term, you have to find the common difference first, right?
6.
Yes, common difference is 6. So that's the idea. If you get a sequence to write the next term, firstly you have to find the common difference. It's very simple. Subtract two consecutive terms. Take the difference. Okay, so you can take the difference of 4 and 10. That's 10 minus 4 is 6. So 6 is the common difference in the first sequence. So the next term will be 22 plus 6, that is 28. Then the next term is 28 plus 6, that is 34, etc. First one is okay. Then the second sequence, 1, then minus 1, then minus 3, then minus 5, etc. Is this an arithmetic progression?
Yes.
Yes.
Yes, right. Okay, it is decreasing by 2. That means adding minus 2. So to find the common difference, you can do minus 1, minus 1, minus 1 will give you, that's minus 2, right? So the common difference will be minus 2. Fifth term in the sequence will be minus 5 plus minus 2. That is minus
7.
minus 9, etc. So second one is also an arithmetic progression. Then third one, minus 2, then 2, then minus 2, then 2, then minus 2, etc.
No.
No, right?
No.
No.
This is definitely not an arithmetic progression because it doesn't follow the definition. To get the second term, what we add 4. Minus 2 plus 4 gives you 2. Then to get minus 2, the third term, from the second term, what we need to do, we want to subtract 4.
Minus 4.
Yeah, this is an alternating sequence, not arithmetic progression. Such sequence we will learn in higher classes. So it doesn't follow the definition. First we add 4, then we add minus 4, then we add 4, then we add minus 4. Only the difference is we add 4 and minus 4, but the definition says that adding a fixed number. Here it is not a fixed number, there are two numbers that's alternating. So this is not an arithmetic progression. So we don't want to write the next terms. So the fourth question comes to fourth question. 1, 1, 1, 2, 2, 2, 3, 3, 3, etc. Is this?
No.
No, right. Very good. Second term is formed by adding 0. But to get the fourth term, we add 1 to the third term. Third and fourth position, if you take the difference, you will get 1. But in the first and second places, if you take the difference, you will get 0. If in at least one place, if you get a different difference, so you can conclude that the sequence is not an arithmetic progression. We'll come to that. Okay, so we'll see how to prove this using algebra, using the general form. Okay, so the last sequence was 1, 1, 1, then 2, 2, 2, then 3, 3, 3, etc. Okay, so before that, I write here a symbol sequence, that is 2, 4, 6, 8, etc. So this is a sequence of even numbers. So this is an arithmetic progression because we are adding 2. Okay, so we give the first term as A. Okay, and the common difference D. What is D here?
2.
A is 2 and D is also 2. Okay, and we give names for each terms. So we don't use separate letters, but we fix a letter and we use suffix to denote the position. Okay, so this 2, it is A, and you can also write A1, no problem. Okay, and the second term 4, we can use A and suffix 2. 2 denotes the position. Okay, then the third term 6, we can denote like A3, then The 8, the fourth term we can denote like A4, etc. Okay, so A1, A2, A3, A1, A2, A3, A4 are in arithmetic progression. Okay, in this example, A1 is 2, A2 is 4, A3 is 6, A4 is 8. Okay, now comes to this question 1, 1, 1, 2, 2, 2, 2, etc. Here, what is A1?
1,
A4?
1, 2,
Okay, A4 is 2, A5 and A6 are also 2, and A7, A8.
3.
3.
Okay, so to prove that this is not an arithmetic progression, it is enough to show that the difference of any two consecutive terms in two places are not equal. Okay, so we can see that here A2 minus A1, A2 minus A1, what's the difference? That's 1 minus 1.
0.
Okay. Now you choose some other position. So I take the third and fourth position. So A4 minus A3, A4 minus A3, what will be the difference?
1.
2 minus 1 is equal to
1.
1. So we comes to different answers. So in this sequence, there is no fixed number adding with the previous term to get to the next step. There is no fixed number. That number is changing. Okay, so it doesn't follow the definition. So this is not an arithmetic progression. Okay, and if you come to the right side example, we know that this is an arithmetic progression. If you take A2 minus A1, if you take A2 minus A1, what will you get?
2.
2, right? And if you take A3 minus A2, what will you get?
2. 2.
2. And if you take A4 minus A3, what will you get?
2.
It will continue like this. A2 minus A1 is equal to A3 minus A2 is equal to A4 minus A3 is equal to A5 minus A4, etc., etc., etc. And finally, you can generalize this idea. In any arithmetic progression, a k plus 1, that is the term in the k plus 1th position, minus the term in the kth position will be same in all the places. Okay, A2 minus A1, here k is 1. K plus 1 means 2. 1 plus 1 is 2, and k is 1. Okay. In second case here, k is 2, k plus 1 is 3. 3, so 3 minus 2 is same, and A4 minus A3 is also same. And if you continue like this, A100 minus A99 will be same, and A1000 minus A999 will be same. So that means in arithmetic progressions, the difference between any two consecutive terms anywhere will be a same quantity. That idea we generalize like this: ak plus 1 minus ak is same in all the places. For all k is a natural number. K is a natural number. 1, 2, 3, etc. Okay. In any arithmetic progression, ak plus 1 minus ak will be same for all k. But in this example, in this negative example, this is not true, right? Ak plus 1 minus ak is not always same here. Okay, so we conclude that this is not an arithmetic progression. Okay, so you got a new idea how to denote each terms in a sequence. So I give one more example. I write here for a simple example 5, 10, 15, 20, etc. So please give what will be the A1 symbol?
5.
When you just what will be A10, 10th term?
50.
50. Very good. A10 will be 50. Numbers are the multiples of 5. 10 times 5 is 50. So the number or the term in the 10th question will be 50. So come back to a third question. You try, please. Very simple question. First one, which is the first term, A1. Common difference.
Minus 2.
Minus 2, very good. The second one, which is the first
-5.
minus 1. What is the common difference? D.
Or
The first first term you can simply write a is equal to 3 in first case, first example, a is equal to 3 and d is equal to minus 2. Simply you can use the short forms. In second one, a is equal to minus 1, b is equal to d. What is d in second one?
4.
4. Very good. Okay. Now comes to third one. What is a? The first term. A is
1 by 3.
What is d?
4 by 3.
4 by 3 is correct. Now fourth question. What is a?
0.6.
0.6. Okay. Then what is 1?
1.1.
1.1. Very good. Finite and infinite arithmetic progressions. So, sequence of even numbers. So 2, 4, 6, 8, etc. It is going infinitely. Okay, it goes to infinity. So that's an infinite arithmetic progression. So finite progression, we can take the example yesterday we have discussed the steps of ladder. Only 8 steps are there. Then there is no 9th step. Okay? Or I shall show the question. This was the one. 45, 43, 41, etc. And the sequence terminates at 31. There's no more terms. Okay, but this is also an arithmetic progression because it follows the definition. To get each term are formed by adding a fixed number with the previous term, except the first term. So it follows the definition. It is an arithmetic progression, but this is not infinite. It's a finite arithmetic progression. Very simple, right? Infinite arithmetic progression means the terms are continuing to infinity. There's no limit.
Non-terminating.
Not alternating. We cannot alternate like 3, 1, 3, 1, 3, 1 or 2 minus 2, 2 minus 2, 2 minus 2. We cannot. But we can alternate with a single number. We can repeat a same number. That's fine. Okay. I got the idea. Sequence of natural numbers 1, 2, 3, 4, etc. Is that an arithmetic progression? Sequence of natural numbers?
Yes.
Yes, right. What is the common difference?
1.
1. Is that a finite sequence?
No.
No.
No. Is that infinite?
Yes.
Okay. The sequence of multiples of 6.
6, 12,
18.
18,
15,
24.
24.
Infinite sequence.